Hello, everyone. It's me, Carolyn, and I am going to talk in this video how we can use the normal curve to answer probability questions about proportions. So first of all, just a little bit of background as to notation and definitions and results before we do an example. So first of all, a definition. Suppose we have a simple random sample in which all of the individuals either do or do not have a certain characteristic. So basically it's like they have two options. They do or they don't. Our sample proportion, which we will denote with this little P with this little accent over the top, is going to be found by calculating X over N. First of all, before I go further, this P with the accent over the top is read as P and then hat. So P hat. Look at that as a little hat on top of the P. The X that we have is the number of individuals that have that characteristic that we're looking at, and our N is the size of sample that we're looking for. So what we're going to be doing is this P hat is going to be a statistic, which is like a measurement of a sample, similar to a mean or a standard deviation or something of that nature. That's going to estimate our population proportion, because we're not going to go out and ask everybody in our population if they do or do not have this characteristic. Well, it turns out that this P hat, this sample, we have a random sample size N, this P hat, the sampling distribution for this is going to be approximately normal, provided we have this N times P times 1 minus P is bigger than or equal to 10, which happens a lot of the time. And if we have this happening, first of all, it is approximately normal, so it follows that bell-shaped curve, and our mean of that distribution is going to be our population proportion. And also further, the standard deviation can be given with this little piece of information, as P times 1 minus P all over N. Okay, so we have, first of all, that it is normal, if we can get this to be qualified, and that we can know its mean and its standard deviation. So then we can go and standardize things, use our tables, use technology to answer questions about probabilities. So we're going to do an example. And as I'm walking through this example, it may look a little familiar to you, which is true. So here's my example. We have a national study that's going to indicate that 80% of college students prefer pepperoni pizza to all other pizzas. I made this material up, so this is not a true situation. This is just a made up number, so that 80% may or may not be the case. But for this example, it works fine. And we're going to be taking a simple random sample of 200 college students, and we're going to ask them if they prefer pepperoni over all other types of pizza. Now, the question we are asking ourselves is, what is the probability that 154 or fewer of these students preferred pepperoni pizza? Okay, yes, these problems resemble a binomial situation. Yes, they are in fact a binomial situation. However, we sometimes, with this large sample size, calculating binomials is long and tedious. It can also bog down our computing systems. So by approximating it with a normal curve, it simplifies our situation. But I'll talk through how we would have used the binomial as well when we're doing this problem. So what we're asking ourselves is, we are asking, what is the probability that our X, or the number of people that like it, is going to be less than or equal to that 154? Now this doesn't have any proportions in it, so I'm going to turn it into our proportions. This is the number of people we're looking for. So our P hat is going to be that 154 out of our 200. Okay, and I can write this as a decimal, or I could leave it in terms of a fraction. I am going to turn it into a decimal because our P that we have for this problem is also given. All right, I'm going to verify that yes, this follows our normal situation. So I'm going to check to see if our n times our p times 1 minus p is bigger than or equal to 10. And if that's the case, I can use the normal curve to approximate this situation. So my n, and again, is my sample size. So that's my 200. My p, that's the proportion that we have, and that's stated in the beginning of the problem. That's this 80% that we're talking about. So I'm going to take that 80% and turn it into a decimal. And then I'm going to also multiply that by 1 minus 0.8, which is my 200 times my 0.8 times my 0.2. And if I do that on my calculator, get out my buttons here, I find that that number is 30, which is bigger than or equal to 10. So this situation is going to be approximately normal. And I can then use the normal curve to approximate it. So I'm going to first of all rewrite this in terms of proportion. I want to know what is the probability that my proportion is smaller than this 0.77 that I had. Okay, I'm going to backtrack just a little bit. Like I said earlier, this is a binomial. So if I were doing this by hand, I'm going to think back to binomials, I'd have to calculate the probability that x was 0, 1, 2, 3, 4, 5, all the way up until 154. Or use technology and that cumulative feature, StatCrunch, using the binomial to get those values. Again, a lot of work. And when you're doing this, if you remember that formula that we had, it had a combination piece in it and it had some exponents in it. The calculator has to, or the computer systems even, have to calculate that piece every step of the way and then add those up. That's a lot of computing power. Hence the reason why using the normal curve to approximate it is the way to go. Okay. This is normal. We just kind of showed that, yes, we can approximate it using the normal curve. So I'm going to now draw a picture. Again, for this example, I am going to use the table just to kind of go old school. I'm also going to then go to Excel to verify my answer, and also again to StatCrunch to verify there as well. So kind of drawing a picture. So it is approximately normal. And it will be centered around the P. Now the P is not P hat. P hat's the piece we have questions about, but the P given in the problem. So there's my 0.8. And we're looking at this 0.77 or below. So we're kind of looking for this region here. All right, now what we need to do is we kind of need to standardize this for if I'm using a table. The old school, I have to use my table. Standardize it, we're going to find our z-score. That's by taking our data value minus our mean divided by our standard deviation. And our standard deviation formula is kind of ugly because it's that P, that 0.8, times 1 minus P all over N. I am going to clean this up a little bit in the bottom here at 0.77 minus my 0.8 all over square root 0.8, 0.2 over 200. And I'm going to let my calculator do the work. And hopefully we can see this. I don't know if I can here. It's kind of dark. Turn my light on. Ooh, there we go. We're going to do that 0.77, 0.77 minus my 0.8. Going to get that value. And I'm going to have to divide it by this ugly square root. So I'm going to divide by, hit my square root button. There's my square root. Notice the parenthesis pops in. We're going to do a 0.8 times 0.2 divided by 200. Close off that parenthesis. Hit my equal button. And I see a negative 1.06066 and so on. Okay. I'm also going to now go and use my table. I'm not surprised that it was negative because remembering z-scores being positive or negative tell us kind of what side of the mean we are on. We are on the smaller side of the mean, so that is why we get the negative. Remember standardizing, this would also go to 0. And now I'm going to use my table. So we're going to go to the table and look up that negative 1.06. So I'm looking on the negative side. Negative 1.06 is 0.1446. 0.1446. And we get that result. Okay. I'm going to now go back and go into Excel and into StatCrunch to verify this value, just to make sure we do get that same 0.1446. So please bear with me as I stop sharing and open up a different screen. So first we will go into Excel. Okay, so kind of looking at Excel here. And I want to remind us, we're just going to go into an empty cell, any place in here, and we're going to use this little FX button. This is kind of where all of the functions for Excel are held. And I'm going to go into, and not the most recently used, because I don't normally use the normal, except I have recently, but it's underneath my statistical. Okay. I don't use the normal curve all of the time. It just happens I've been doing videos about the normal curve, hence it's in my list. So we're going to go into this norm.distribution. Okay. If I were going into the standard normal, I could use this one, but since I have the generic one, I'm going to just use that. So I'm going to hit OK. All right, my X, that's the P hat that we're talking about. So that's that 0.77 that we're talking about. Our mean is the middle, that's the 0.8. And our standard deviation, I need to actually calculate. That's going to be the square root of that 0.8 times the 0.2 divided by the 200. So that ugly square root piece that we divided by when we standardized it. And I'm going to go, a couple decimals here, 0.028828. We'll go with that. So 0.02828. So I'm going quite a few digits. Again, it's going to be slightly different than what we had using our table because of where rounding happens. I do want to go all the way up until 77, so I am going to put the word true in here. And I'm going to hit OK. You'll also notice before I hit OK, it does show up in the box. You can see that here we have 0.144. I think that's a 3.8, which is slightly different than what we had. But again, here I did round my standard deviation. If I put in a few more digits, we'll see that it does turn up a little bit more too. So as we increase in the accuracy of our standard deviation, it does lean towards that same value. We're not going to get it exact because you notice we also rounded our z to that 2 decimals, that 0.06. If we were to go more digits, we would get them to be more close together. But again, there's our 0.144, and then we had some more digits. So depending on technology, it's going to be a little bit different from one piece of technology to the other. Okay, that was in Excel. Again, the FX key, the normal distribution, put your X, P hat, and then our P given in the problem, you have to calculate that standard deviation, that square root piece. And then I use true to get the left hand tail. If I were looking for a right tail in the picture, I would do a 1 minus then. If I were doing a between, I would do it for both values and then subtract. Okay, in StatCrunch, which is another technology that some students use, I want to kind of remind us how that works. So I'm going to go into Stat. So here is my StatCrunch, into Stat, under Calculators, and we are using a normal. So under the normal, we could be doing a between or the standard. In this problem, we are doing a standard, so one tail. Our mean, that is our 0.8 that we had. Our standard deviation was that square root piece that we had, so 0.02828, and I'll just go with a few more digits because I have them. So 4271. We are looking for our X being less than 0.77. And the nice thing about StatCrunch is it does give you that picture that we had drawn earlier with the 0.8 in the middle, 0.77 on the left-hand side. We were going less, so we shaded that region. And there is our 0.1444218, which is what we did see in Excel. It is slightly different than what we had using our table, and that is all due to rounding. So this is an easier way to approximate probabilities of proportions instead of using the binomial, which has a lot more calculations. Maybe not by you, but by technology, and sometimes technology speed is important. And I'm not sure how long it would take to calculate it, but you could try it. I believe that would be under Stats, Calculator, the binomial. So just feel free to have some fun and check it out. I hope you enjoyed this video. I hope my videos are helping you get a better understanding of statistics and the statistical world. Hope to see you in future videos. Bye.